Hi and welcome to TRX Bench. Today we have ICOM IC-756PRO3 and this radio will produce a kind of self oscillation, so that is a fault description when it comes in. So let's see if we can really confirm this finding, and let's see what we can do for this nice radio. Alright, and here is our IC-756PRO3, and let's go into the testing. And yes, the radio is firing up, and you see 756PRO3, and yeah, it takes always a while until the computer has booted, and here we are. Very nice. So okay, the fault description is that when we just press the PTT, that then we directly have output power, and we should not be able to see it as radio is on SSB upper sideband, and therefore we should not see nothing with only PTT, but therefore we reduce our mic gain to 0, and our RF output power we put more or less in the middle here. And then, well, let's see what we can find. So let me see that you can really see both. And now without any mic amplification, as I already said, no output power is required. So let's see. And no. So you see we already have 44 watt, so that is maybe because I have put the output power to the middle. So let me crank it up to the maximum. So RF power is now at the maximum. Okay, but that will not be a chance here. Alright, so what I'm now interested in is, let me go here a little closer. So once again, maybe that it is now more clear. So we are seeing 44 watt output power without any mic or audio input. So now I increase my mic amplifier, and I'm interested if, when I now talk into the mic, if I then see a higher output power. So let me check this. 1 2 1 2 1 2 1 2. Yeah, that is exactly 1 2 what I thought. So we really have output power, and it is over 100 watt. And I'm not 100% sure, but quite a while ago I had a 746 on the bench with a very similar fault, and I wonder if this maybe has developed the same problem, and therefore let me do something. Alright, let me first of all see if we can see both. Again, our power amplifier, not our power amplifier, our power meter, and the radio itself, so maybe it works. And now a little test to see if my thoughts are right. So I will push my receiver attenuation to, what is it? It is 4. It's 4. So now 6 dB, and let me check. I go down with my mic gain once again. Let me check if we still have our 40 watt. Aha, so it is now 36, as you can see. Very interesting. And okay, so this is 6 dB RF attenuation. So let me go for 12. Now we have 12 dB input attenuator selected. You can see it here. Now let's do this test once again. And what do you see? Do you see the same than me? PTT, watch for our power meter. Do you see that? No oscillation any longer. Alright, so let's increase here our mic gain. And RF power is already to maximum. And now let me see what we see. Once again, nothing, which is right. 1 2 1 2 1 2. Hola, audio 1 2. And what you see right now is that we only have 100 watt, which is right, because this is here, as we all probably know, this is a 100 watt rig. And we see with our attenuator in place, so 12 dB RX attenuation, we do not have self-oscillation any longer. And that looks like very, very similar to the fault I had a couple of, I don't know, it's quite a long time ago when I had a 746 on the bench with a very similar fault. And now what I need to do is, let me have a look into our schematic and let me see if the Pro3 has the same schematic as the 746. It was the 746, I believe. Or minimum if the circuit I have in mind is at least similar. And then we have, I guess, a very good starting point. Alright, and maybe let's start here with our block diagram. So you may already wonder that I put attenuation in the receiver pass while we are transmitting, and that with the receiver attenuation our self-oscillation on transmit is gone. Yeah, that sounds very funny, but that is exactly what I experienced with a 746. And yeah, if we have a look here, so this orange here is the transmit line, and the blue here is our antenna input, and the green here is our receiver input. And what you can see here is at least our TX RX relay. So this relay here is switching between RX and TX. And so that is how it's working. And here, over here, so this here is our attenuator. And well, this here are the bypass switches, and we have seen that when the bypass switches are in, so that there is no attenuation, we have this self-oscillation, okay? But when we put 12 dB, 6 was not sufficient, but 12 dB was good to stop this self-oscillation. And that reminds me that we have here around this RX TX switch, we have a little circuit which will normally pull our RX input line to ground, that nothing from our TX signal can somehow jump over into the RX pass and can do funny things. And therefore let us have a better look here in our schematic, and what we can see here is our antenna input. So our blue section, and we know that our green section is our receive pass, and here the orange section is our transmit pass. And that means that this relay here is our TX RX switch. And well, there is another little circuit, and it is not completely similar to what we have in the 746, but this little unit here, this little circuit here, will finally have the same function. So this is the same job this little circuit has to do, and that is nothing but it needs to pull down our green receive pass to ground while we have a transmitter signal outgoing. So very simple, this relay here will switch from the receive function to transmit, and then of course our power signal will go through this relay, and this little transistor here, so I don't know if you really can see it quite well, but this little transistor here will normally put our RX pass directly to ground. So if we have a positive voltage here at our base, this transistor will switch, and what you can see is we have here a direct line from here our green tap, right, to over this diodes directly to ground, right? And that means that this transistor will pull our RX pass to ground, so that if there is somehow a signal jumping over to this tap here, that it cannot go here into our complete receive circuit and will do funny things. And therefore, first what we are gonna look is if this circuit here will have a good function. Alright, and here is our radio open, and what I have just recognized is that when we here watch our CTRL A unit, which is this here, so, and that is also our board of interest, right? We find that, yeah, let me see if I can zoom in here. So you may notice that somebody already was in. So here we have some informations on our coax cable, and so therefore that is a clear indication that somebody was already in. And yeah, what can we see else? So we have here our relays, which we have discussed earlier, and well, now we need to find our little circuit. Alright, and what we are interested in is our Q25 and our diodes here. So these are really of interest, and therefore that is the area which we need to find on our board. Alright, and that is our CTRL A unit, our board plan, and yeah, so let me rotate it, that no, that was too much, so that it is on the screen in the same direction as we have it here in reality. So in reality we have here our antenna output, and we have here our relays, and that is what I've done here as well. And our relay, let me double check, our relay 4, I believe, can't find it that fast. Yeah, our relay 4 is our RX-TX switch, and so let's enlarge it here a little bit that we can better see it. Alright, so here's our RL4, so that is our TX RX switch. And yeah, where is our Q25? So that is the little transistor we are searching for. Oh, sorry, I've just seen you haven't seen it. Sorry. Here is our RL4. So this is our TX RX switch relay. And now where is our Q25? So that is what we need to find. So let me enlarge it, because it should be here somewhere around. So can we already read it? Hang on a second. Can we read the figures here? So that is one moment. Once more. Okay, so this is Q13 and Q2, I believe. Q12. All right. And that is not what we are looking for. So let's go ahead. And what do we have here? What do we have here? And all right, here it is. Here is our Q25. Okay, so that must be from the relay position, right hand side. To, yeah, it is the upper right hand side beneath the L301. So let's see where it is on our board. Okay, once again, our TX RX switch, and this here is our L301, which we have seen on our schematic. So that means this here is the area where we have our Q25. So let's zoom in. What do we have here? 1 second. Okay, and here is our this is our Q25, which is highly interesting to know what's going on here. And then we have here our 2 diodes, which we need to check as well. And just that you get an impression once again how tiny it is. So it is really down here. It is again very, very, very tiny, and therefore it is real SMD work again. So here's, by the way, a power resistor, and we see that this resistor seems to become always very hot. So this is in our, so that is a resistor in our transmitter pass. So that seems to be not really a problem. Maybe it could have been designed a little bit bigger, but that seems not to be really a problem. But let me do our first checks. Alright, and our meter is on diode test mode, and yeah, let's see if I will be able to handle it here somehow around the camera. So that's a little bit tricky, but I try my very best. So there is our Q25, and let's see. So base to emitter 0.3, okay, base to collector, okay, and collector to emitter, which shows also a junction, which is not completely right, but that can be because we are testing our component in circuit, which is always wrong. Okay, so let's check here our diodes. This diode is most probably shorted. And the next one? That is, I'm not entirely sure. I mean, again, it is in circuit, and that is always hard to say. But, well, with this first test, I mean, this seems really to be, yeah, so this diode here is really dead, and the transistor, I'm not 100% sure, so that can be because of, yeah, it's in the circuit. So therefore, what we need to do, I have to take the components out of circuit, and we need to test them out of circuit. Yeah, once again, this here is a diode which seems to be shorted. This one is still suspect, and our transistor, as we said, is suspect 2. So therefore I'm gonna take them all out and check them out of circuit. Alright, and our components are out, so 2 diodes and our transistor, and now we're gonna check them. Alright, and here are our 3 components which we want to check. Here on the left, this is our little NPN transistor, and yeah, the wiring is that we have here on the left down, so that is the base. This here is our emitter, and here the upper one is our collector. So what we gonna check first is our base to collector, and don't know, let me see if we can do both somehow. It is a little bit tricky. Okay, so that looks good from base to collector, and from base to emitter looks good as well. So now let's change polarity, and we check from base to collector, which seems to be good, and now from base to emitter, and hello. So that is definitely not good, so that is wrong. So there should not be a connection from base to emitter if we feed base with negative. So that is wrong. And now let me check from collector to emitter. And yeah, so that is definitely wrong. So there should no continuity between collector and base, so that is definitely wrong. Let me check it other way round, just for clarification, and have a look. So we have here again continuity from emitter to collector, and that is definitely telling us that this transistor is dead. And now we have here our high voltage pin diodes, and these diodes are connected like we have here down on the left hand side anode, and here the upper one is cathode. So we check first from cathode with from anode with plus lead to cathode, which should be good. It's a little bit tricky, we know that. Yeah, and that is not good. So that is a short we have already seen on the board. So let me change here my polarity. Yeah, definitely. So this is shorted out. And let's check the other one. So that is 0.2. And let me change polarity. Yeah, and this one is reading also 0.1 volt. So this is the reverse direction, and we should not read any. So that tells me that all of these three components are dead. And so it is no wonder that our transceiver don't work, because well, if this circuit with these components is not able to pull our RX path to ground, then our TX signal goes into the RX path. And in the RX path we have really a lot of band pass filters, and that means there is enough or there are enough capacities and inductors and what have we. So enough stuff for our TX signal to do funny things. And the funny thing is that it starts oscillating. And yeah, no wonder. So these circuits here are dead. Unfortunately, I do not have them on store, so I have to order them, and then we will see what's going on here. So our components arrived today, so we can go ahead with our repair. And yeah, so these are our high voltage pin diodes, and you can't really see them because they are so tiny. So let's see, here are our pin diodes we need, and here in this package we have our transistor we need. So alright, that means we can go ahead and yeah, let's bring the new components here into our circuit. Okay, and for all who want to see the difference between the faulty component and the new one, so I have placed down here the new component, and yeah, let me exactly do the same. I hope you can see it. Not so easy. Let me double check, maybe that way, but you can see our meter, and that is base to collector, which is good, and now base to emitter, which is good. And now we change polarity. So that is what we have done with the faulty one as well. And I feed negative into the base, and I check then our emitter, and you see that is now silent, which it should. So that is good. And then we checked with the faulty one, collector to emitter, and that is this way here, and you see there is definitely no continuity in any way. And now I change polarity once again. Yeah, that is a little bit okay. So now polarity changed, and I do it the other side round, and you see there is no continuity in any way. And once again, if I go up here to the old and defect transistor, and yeah, see this here, so there we have continuity from collector to emitter. And when I now change polarity like so, and I do exactly the same test, then I have again, you can see that. So we have again continuity in both directions, and that is what we identified as fault. And that is what we do not have here with our new component. And that is the proof that really our old components are dead. So that is for all of you who wanted to get it compared, to get a feeling how good and a bad transistor looks like. And now we put our good one, this here, we put into our circuit, and of course we put our pin diodes into the circuit as well. And then let's see if our radio will work again. First of all, we give now the board a clean. So I zoom in that you see where we need to work. And yeah, already focus is gone, but I think that is where or how we can see it a little bit. So down here in this position here, so this is our transistor, and here are our both pin diodes. So first of all I clean out the board, and then I will put in the new components. Okay, and the new components are in, and yeah, I just want to remind you, so this is nothing for anybody who has no experience with SMD soldering, so you really can destroy your board, you can destroy your radio. So really nothing for young player. Please, if you do not have the right tools and the experience, bring your radio into a radio shop, because otherwise you definitely will destroy it. Yeah, right from this position here you can see here our three new components. So this here is our transistor, and here are our two pin diodes. So they are, as I already said, in. Now I'm going to clean the board a little bit, and then we are ready for testing. Okay, so board has been cleaned, and now we are ready for testing. So let's switch on and let's see what's going on. Okay, so radio is booting, and let's see. Okay, we have static. Very nice. So let's set our microphone here to the radio. Very nice. And let's pull down here our mic gain, and let's set the audio a little bit lower. And okay, so let's see. Transmitting. Interesting question is, what's going on there? No oscillation. Okay, we have still here our 12 dB in, so that should of course out. Now the internal attenuator is off, and that is now of course the situation where we should not see any oscillation. Yeah, still our mic gain is turned down, and yeah, let's see what we have. Now we have the right setting, and what do we see? Very nice, no oscillation. So that is already good news, but that is of course not all, because we have seen when we had the fault, and when we put here our power output to maximum, you have seen with the fault and with speaking into the mic, we have seen peaks up to 160 watt, and that is of course something we do not want, and of course together with all the oscillations. So therefore power is now full, and yeah, let me put our mic gain to, what is it, 1 o'clock, so that might be okay. So let's see what we have. Still no oscillation, which is good. And now let's see. 1 2 1 2. Hola, 1 2. Hola, 1 2 3. 1 2 3. Audio 1 2. Yeah, and what you can see, that is exactly what we want to see. So no oscillation any longer. So our radio is working in SSB. So that is great. But let me double check. If we go here into 28 to 28, I don't know. Let me go here to 415, whatever. So let's go into the 10 meter band. And let me see. Yeah, upper sideband is right, and let me see what we have here. And that is important, that we do not have any oscillations here in our higher or on our higher frequencies. And you see no oscillation. And now let's talk. 1 2, hola, 1 2, audio, 1 2 3. Test, 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 1 2 3, audio. Yeah, and we can only say that our radio is really back to work, and it really can go back into service. And it is really a shame that this radio has been at ICOM Europe, and ICOM Europe refused the radio with the comment, we can't fix it, we cannot find the fault. And yeah, for me that is embarrassing. The question is it a sales strategy, or what are these guys doing? So is this radio already too old? Do they focus on selling new products? So, you know, that from my point of view, but I might be wrong, but from my point of view, this is really embarrassing if this radio are considered to go into the waste. So therefore, okay, so build up your own opinion. So that is the experience we have with this radio. It has been at ICOM Europe, and they said they cannot really repair it. They cannot find the fault, and therefore they send it back not repaired. Okay, anyways, we have now a nice working radio, and it can go back into service, and so therefore our repair is at its end. And as always, if you like this video, please give me a big thumb up, and if you have not subscribed yet, please subscribe, and you will not miss any new videos. And well, so far I would say catch you next time, and bye.